Okay, let's see what we got here. Makes them divisible by p. So I previously solved this. Given an an array of positive integers, nums, remove the smallest subarray, possibly empty, such that the sum of the remaining elements is divisible by p. It is not allowed to remove the whole array. Okay, return the length of the smallest subarray that you need to remove, or -1 if it's impossible. Subarray is defined by a contiguous block in the array. So it has to be divisible by 6. The smallest subarray. So the smallest subarray is defined by the size. So I think removing the 1 and remaining 9. You could also technically remove the 4, get 6. Some elements is 10, which is not divisible. We can remove the subarray 4 and return the length. Okay, never mind. It is the actual cares about the length rather than the value. I guess the value. Okay, I mean those are two different questions, but sure. Doesn't matter if we get like the lowest or highest subarray total. It's just the length. Okay. Interesting. So first thing, whenever I see a subarray type of question is there like a sliding window technique that can be used to find this subarray? So if you have like a right index that's that you're iterating through for in your for loop. So you have a right index, and then for each index you go to the nearest left indexed that is appropriate to make the window to make the remaining elements in the array divisible by p. I think that probably works. So the nearest index does that work? So you go through the right indices of your window, and then you close the left side of the window such that your the values in your window have to be a certain value within the kind of mod p. But the question is whether or not you can always do that regardless of the right side. Like if you're closing your window on the left side, does that still apply to the next right index? And I want to say no. Okay, so here this total sum is going to be 10. The sum of, so if the total sum is 10, that means in P6 that's a remainder of 4. So your window actually I skipped wrong when I said that. It could be removed 1. I think I was thinking maybe P was 3. So remainder is 4. So your window has to have a total of 4 mod 6. So right is 3. You can't really close the left side, right? Can't close the left side. total is 4. So it could be 3, 1 that you remove, or just a 4. So if you're at the 3, I guess I can think of this as if you're on the left side of the window, how far to the right would you go to get the needed target mod value? In this case, the target mod value is 4. How would you do that consistently? Obviously, if your value is the target, then you just return 1. If your value isn't the target, then what is P? Well, P is really large. If your value isn't your target, then you'd have to go to I don't think you want to extend the right side. That'd take too long. If for every value do some sort of prefix sum. Alright, let's look at the second example. This adds up to 16, and you need to remove 7. So this is not 7. So here you need to extend this to include a 1, which is everything. I guess everything is always going to work, no? Is 0 not divisible by p? Oh, it is not allowed to remove the whole array. Yeah. Wow. That was a reading fail right there. So yeah, you can't remove 6, and then you have to extend it to include another 4 or 3, and you have to extend it to include another 7. No, 3 you need to what's going on here? 3 you need to include 4 more. 5 you need to include 2 more. Okay. 1, 2, 3, not possible. It's 6, 6, 3, 5, 2. Oh, sum is 17. What's it? 16. Odd 9 is going to give you 7. So that's the target. So 6 would need 1, or 3 would need 4. 5 needs 2. 2 is impossible. Man, there still feels like there should be a very, very simple or relatively simple way of doing this. Relatively simple way of doing this. For every value, for every value. Ooh, some idea here. There's some idea here. The closest preceding, so it could either go backwards or forwards. So 6 needs 1, so the first thing before 6 that gives you 1. 3 needs 4, the first thing before 3 that gives you 4. If you think about this as the index, if you think about this as the right index or right value to the window, 5 need the first index that gives you a sum of 2. And then 2, the first index gives you a sum of 5. Hmm. 2 is 5. How would you keep track of the stuff before it? Could maybe use heap doesn't work because you're not really sorting it. Like if you had for a certain right index, every index before it has a every index before it has alright, let's go ahead and just do some sort of prefix sum. So let's say the sum of the first k elements within this array is going to be 6, 9, 6, 9, 14, 17. Six, 9, 14, 17. Interesting. Just also do this is the prefix sum. I'm going to do the suffix sum. So this is 17, 14, 9, 2. No, 7, 2. Oops. Is that right? 17 minus 3 is 14 minus 5 is, oh my god. Why can't I add 17 minus 6? Oops. 11 minus 4 is 7. Minus 5 is 2. Okay. Then if I do the prefix sum mod k, mod p is going to be 6, 0, 5, 3, no 5, 8. Oh my god, I'm thinking the sum is 17 rather than 16. Still stupid. No wonder these numbers didn't work. 10, 5, 2. And there we go. 7. And this is mod p. Mod p here, this is going to be 7, 1, 5, 2. So subarray that you're removing needs to have it such that the stuff that is the sum of that subarray is equal to the target. Is that right? Sum of that subarray is equal to that target. That doesn't work, does it? No. No. Okay. The difference between the start and the end of the subarray in the prefix sum is the target. The difference in the start to end of the subarrays and the prefix sum is the target. Then why doesn't this one work? So 0 to 7, 1 to 2 doesn't work. 16 mod 9 is 7, 10 mod 9 is 1. Maybe I'm just assuming backwards, really. Maybe I just think about the forwards version prefix sum. So 0 goes to 7. Does that work for everything though? Let's see. Do the first one, 3, 1, 4, 2. P is 6. Sum is going to be 3, 4, 8, 10. This is the prefix sum. Mod P is going to be 3, 4, 2, 4. This is mod P of the prefix sum. And then here, this is target is going to be, sum is going to be 10. Target will be 4. Ooh, that doesn't. Technically, 4 to 2 is 4. Guess it'd be 4 to 6 is 2, and then 0 to 2 is 0 to 2 is 2, so that's 4 right there, which corresponds to removing this element. Yeah, so this is 1, this is 4 because it wraps around. This is 2. So here 4 would target 2. Would target 2. So if I kept track of, for each mod value, and for each mod value in the prefix sum, the indices where it occurs, and then I look at the mod value that I'm after, and ignore the ones that are before this index, because those would have already been accounted for, I think, until I find the closest one accurate. And then I take that as the smallest window for this index. Do that for every index. Okay, I guess that might work. So this is going to be, so I'm going to generate prefix sum mod p here. Well, actually, I think I need to generate the sum here. Total is equal to sum of the array. Target value for mod is going to be total mod p. And then I'll do the prefix. Current is equal to 0 for every index in range n, where n is the length of the array. I'll take the value and add it to the index, or to add to the current total. Current plus equals nums at index, prefix sum appends the current. I could also have prefix sum start with 0. Maybe that might be better. Then I don't have to worry about keeping a current value. It's just the prefix of -1 at -1. Prefix append prefix at -1 plus current value at this index. And then, actually I wanted to make that mod p. Okay. So then what's next? So then I do the sliding window, yes? No. Actually, I need to do one more thing. Okay, I actually do need to make this into separated. Let's say pre-value is going to be prefix at -1 plus nums at index mod p. And I do need to have, I guess it'd be a default dictionary of lists. I'm kind of worried that p is just a very large value. There's a lot of things that could be stored in p. I guess it still is at most 10 to the 5th things. Okay, so this is going to be early or remainder indices, remainder spots, I guess I'm called. This is going to be a default dictionary of integers. No, default dictionary of. I kind of want this to be a queue. That is annoying, isn't it? I want it to be a queue, but then, yeah, that's fine. Double-ended queue. Is that the syntax? Or is it just deck? Yeah, what is the syntax there? Okay, yeah, it's default dictionary deck. Wasn't sure if there was a parentheses maybe, but if I type this as a list, it actually colors it differently than if I type it as a deck. Anyways, this is going to be the key for this default dictionary will be the prefix mod value, and the target or the value of that at that dictionary entry is going to be the list of indices where that occurs. List of indices in the prefix in prefix array. Yeah. This list of indices in prefix. So here, so that's the value in the prefix array. I append that value, and I do the entry in the default dictionary. So rem spots for this pre is going to append this index. All right, let's go and just do a quick check here to make sure if it's working. Print my prefix. Yeah, print my prefix. Print my dictionary. Dun 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 dun. Okay, so let's see which one was I working on. 3142, so the first one. So I expect my prefix sum should be 3424. 3424. And then the earliest occurrence of 3 is 0, 4. There should be list or a queue of 1, 3, and 2. It should be at 2. Okay. So then for every, so then the goal is to get the target, the smallest target, the smallest subarray that gives me a target. So for every index in, actually say answer is, I guess I can start with answers the whole length. For every index in range n. So I get the current prefix target. I get the current is it going to be range n? I think so. So I look at the current spot in the prefix array, and then based on this spot, I define what I'm targeting. So if the target, say, or I find what the sum is with that in mind. So if the target's like 4 and the current is 0, then I'm looking for 4. Or if the target is 4 and the current is 4, then and the p is 6, then I'm looking for 2. So I think it should be, what's the calculation? Because it has to wrap around, like 4 goes to 2, and p is 6. So it should be current plus target mod p is the goal. Goal is going to be current plus target mod p. And then I can do something like, while there's something in the queue at this goal goal spot. So rem spots of goal, while that and rem spots at goal, the index there is less than this current index. Is that right? Less than or equal to? I think it might be less than or equal to. Oh well, let's go with less than for now. Rem spots at goal, pop left. So it removes that front from the queue that's outdated or kind of on the left side. And then I can say if rem spots at goal, if that exists, then the answer is equal to the minimum of the answer and rem spots at goal minus this index plus 1. Alright, I just gotta do the actual math here to see that it works in some form. So this is the prefix sum mod p, it's gonna be 3042. So if the index is 2, then the current is 4. The goal is going to be 2. The goal is going to be 2. And then the index of 2 is actually 2. Why would this be 2? 0, 1, 2, 3. I guess I didn't actually store. Oh yeah, okay, yeah. When I was doing this, the index didn't actually match the placement in the prefix because this has 0 at the very start. So I guess that's fine. So the index 2 here is at 3. So 3 minus 2 is 1. So that's fine. Alright, and then if the answer ends up being equal to n, then return -1, else return the answer. So return -1 if answer equals n, else return the answer. Collection, rem spots at goal is less than index. Oh, this should be, I'm looking at this wrong. This should be, this gives me back the queue, so I look at the first entry in the queue. I guess it should be less than or equal to, because it can't be actually equal to 0. Well, can it be equal to 0? Unsupport operand -1. Yeah, oops. I guess if it's equal to 0, then that just means that it should have been that should have been a trivial case. So I can say here, if the target is 0, return 0. You don't have to remove anything. Okay. Ooh, baby. I'm not getting their answer. So this is returning 0. How is this returning 0? Whoops. Three, 1, 4, 2. Total to mod p. Okay. Total is 10. Maharga is 4. It's returning 0 from this thing? Really? Huh. Okay. Must be. Oh, I wonder. If I need to do length is greater than 0. I think it should be less than or equal to. Okay. Well, stop giving me 0 for the first case, which is good. So I didn't solve this one. Escape 1. Gave me 1. 6, 3, 5, 2. Okay, so let's go ahead and print out what is the stuff here. Okay, 6, 3, 0, 5, 7. Okay, I think that's what I expected, right? 6, 0, 5, 7. Okay, first instance of 6 is 0, first instance of 0 is 1, 5 is 2, 7 is 3. Okay, and then let's go with printing out the current and goal. I guess I should probably do index as well. Alright, index 0, the current sum is 0, goal should be 7. And maybe I can do what that's possible. So 0 to 7. This should say not possible, but maybe it just calculates it as the whole array. Anyways, next one is 6, so the goal should be 6. That's not possible. The next one is at 0, the goal is 7. That is possible, that should give me 2. That should be 2 right there. Why does that give me just 1? So index there is 2. Oh, what is going on? Index there is 2. Wait. So I'm at 3? No. Should be at 5. 0. I should be at 3 and going to 2 here. 3 represents... Oh boy, I'm really screwing up my indices here. I think I first need to Yeah, I think I first need to set up my prefix correctly. So the most spots prefix of index should be +1 here, just to make it actually consistent with what my chain of thought is. And this should make it. Oh, I was pretty sure that was going to make it everything wrong, but I guess that was what was the missing thing. Wonder if this is actually correct. Should be less than or just less than equal to, I guess. Since it's solving the case where it's equal to 1 correctly in this, then it must be less than or equal to. Okay. Let's go ahead and remove the prints. Oops, that's not removing it. That's running again. And double checking. Whoops, I think I want to run that and then just submit. Oh, eeks. Alright, well, it works. Obviously, it doesn't work very well. Okay. Ooh. Yeah. There has to be some sort of more elegant solution here. So for every value, well, let's see what, I think this indicates to me that this should be done, I mean, I'm pretty sure this is linear. Yeah, I'm pretty sure this is linear. It just needs to be done in a faster linear way. I don't think this is like an order of magnitude faster somehow. I mean, I guess it can't be much faster than linear anyways. But it's just doing several operations. I see. I see. I should be just looking at the backwards version of this. So this is kind of like a sliding window from the left side, where index is the left side of the index, left side of the window, and the right side is being tracked. The possible right side is being tracked by this default dictionary. I just need to do it first. So it needs to be right side. I keep track of the nearest left side index that is appropriate. Okay. I think this should just be a default dictionary of integers. And then the key is the prefix mod value. The value is just the last index in prefix that it occurred, that this occurred. Okay, so I don't actually need to do this. I don't need to keep track of it the QA. I do need a prefix. Well, do I even need a prefix? I can probably do this on the fly. Or a prefix mod value of last index last occurrence of prefix. Okay, so it should be something like index in range n. Say the current is equal to 0. Prefix is equal to prefix. I think maybe I need move spots of 0 equals 0. I think I need that. Okay, I think I need to update my stuff here. So current plus equals the current value in the nums array. So nums at this index. Then I need to find the target. This time is subtracting, maybe. So if my current is 7 and my target is 3, then I need to find 4. So I think it should be goal is equal to the current minus target mod p. Yeah, I mean, this makes sense. If this is going forwards, then this is going, then subtracting it would go backwards. So then if there is something for this goal, if rem spots, if goal is in rem spots, then answer is equal to the minimum of answer. I think this should be index plus 1 minus index plus 1 minus the previous. I think it should be that. And then return answer. This is all. I think this might be correct. Nope. This is just a trivial case. Okay, so I think I need to I never actually added this entry into the dictionary. I think this should be in the dictionary. So rem spots at goal should be this index. Still incorrect. So what is it returning? It's returning 2, 4. Okay, so let's just go through. Go through an example here. So let's do this one. So P is 6, target is 4, value is 3. So the prefix, oh, this is mother. Current should be equal to current should be current plus nums index mod p. Oops, I forgot the mod. Network. Still incorrect. Okay. So it'd be 0 plus 3, mod 6 is 3. Goal should be, let's go and print this out. Current and goal. Index current goal. Okay, so index 0, total here is 3. which is what I expected, right? 3, 4, 3, 1, 4, 2. 3, 1, 4, 2. Whoops. It's not getting the current. What am I looking at here? It's not getting the current correctly. Current plus nums index. Mod p. 3 plus 1 is 4. 4 plus 4, 8 mod 6 is 2, 3, 4, 2, 4. Actually, no, that's right. 3, 4, 2, 4, yeah. Okay, so the target was 4, so 3, you need to find 5. 4, you need to find 0. 2, you need to find 4. 4, you need to find 0. Okay. So that's fine. Okay, let's go ahead and do size is equal to index plus 1 minus rem spots at full. Print bound. Okay, so the first thing didn't find anything. Second thing found 2. Huh, there should have been 1. Well, that simple answer here would be just remove the plus 1 from that. But then this is off by 2. Okay, so let's go ahead. How did it find 4, I guess? Or how did it find 2? So the index here was 1. Is that the correct index that I'm thinking of? Yeah. So 4. 1 plus 3 is 4. No, so this would be 1. 1 plus. Yeah, this found 2 is correct actually. I guess the second one is not. This one that's an issue. Four finds 2. Current is 2. The goal is 4. Oh. Hmm. Hmm. 4. Current is 2. Wait. Current is 2. The goal is 4. That should be findable. Ah, my God. Oh, God. Okay. Well, I think that is better. Definitely should be ref plus. The current is equal to index rather than the goal is equal to index. Found 2. This is right. This should be 1. Found 1. Where 1 is the size of that window. Index is 2, which is this spot. And 4 is the goal. And that should find it at this index, which is 1. It's 2 minus 1 plus 1. Okay, yeah, I screwed up again. This rem spot's current is supposed to be index plus 1, I think. Or it's supposed to be index and then the current should be starting at -1. Rem spots at 0, so -1. Oh, it's off by 1 now. So that means I should need to remove the index plus 1 here. Oh god. Off by 2. Output's 3. Expected 2. Okay, should be -1. Not the greatest coding logic I've ever done. Output still 2. Found 0. What the heck? Okay. This should go back to... Oh, I'm changing the size printout and not actually changing anything. Fuck me. Alright, I think this should work. Okay, current and goal, remove that print. And let's see if this is better. So now it's incorrect. -1. I guess. So my logic for the answers not appropriately pasted over. Okay. Okay. Alrighty, that's a wrap, I guess. So let me tidy this up. And this all goes away. And I guess I can just redo this. Okay, so I guess this is the main thing, main example. So, sum, total, trivial, prefix. I don't actually use this anymore. I'll do that on the fly. Plain. I guess I call this maybe the last prefix is better. prefix mod value, value last occurrence of the prefix, last prefix. Current, this is the current prefix total. I guess this is the current sum total. Yeah, okay. That's fine. This is occurs in the last prefix. That's probably all correct. Okay, so summary here. This is going to consider how okay, so finding the target mod value based on the sum of the values in the array, and p given should be done first. So that's pretty obvious if you know the number theory of this, right? It's like the values that are added, there's a remainder to it. One is divided by p, and the subarray needs to add up to something that equals that remainder mod p. So if the sum is 10, the remainder is 4 when divided by 6. So the subarray needs to add up to 4 mod in mod 6. So this could add up to like 4 this way, it could add up to 4 here, it could add up to like 10, which is 4 mod 6, which is 4 when you have 10 mod 6. So then consider how this might be calculated using a consider how you can consider how a prefix sum array mod p could be used to find the smallest subarray equal to whose sum equals the target, which is the total mod p. So using a sliding window where the index is the right side. It's kind of sliding window. The left side of window is the closest prefix value where the difference between that and the current prefix value, all this mod p, right, equals the target. So if the target is 4, then the difference between the current prefix value and the previous prefix value is 4. So that's what happens here. Like I have a default dictionary where the last prefix value is stored for a certain current prefix value. The prefix being the value and the key, and the prefix being the key, and the index where that key occurred is the value of that dictionary entry. And then iterating over every index, you calculate the prefix mod p. we calculate what the target was based on this, so that such that the difference between that prefix, this prefix, and that prefix was equal to the target. And then if that exists, because it might not exist, if it exists, then the size of this window is the size of the subarray, whose length is the size of the shortest subarray that has your target. And then if it doesn't, like this is always going to work when the whole subarray is considered, or the whole array is considered the subarray, and return -1 in that case, but otherwise return whatever the answer was. Anyways, this is going to be O of n complexity, where n is the size of the array. Lower methods, which I originally had, were still O of n, but had more overhead, creating the whole prefix array and storing like the double in queue or last prefixes. So basically, like, see, this one is actually pretty compact. I'm gonna say this is gonna be O of n as well, I guess. To store the last occurrence of each of any possible prefix or any possible remainder prefix value, and which is going to be at most the minimum of p and n, which in this case, because p is 10 to the 9th, this is not going to be that much, so it's going to be just n.